Imagine building a complex software system where different parts need to talk to each other, even if they are on separate computers across a network. How can one part ask another part to perform a task as if it were a local function call, without getting tangled in network complexities? In a remote procedure call, or RPC, system, stubs and skeletons are the crucial components that make this seamless communication possible. A client-side stub acts as a local proxy for the remote service, while a server-side skeleton handles the actual invocation of the remote procedure. These two elements are fundamental because they abstract away the intricate details of network communication, allowing developers to write distributed applications as if they were local. When a client application wants to call a remote function, it doesn't directly interact with the network. Instead, it calls the local stub. This stub is responsible for taking the parameters of the function call, converting them into a format that can be transmitted over the network, a process known as marshalling, and then sending this marshaled data to the server. On the server side, the skeleton receives this network request. It then unmarshals, or unpacks, the data back into the original parameters, identifies the correct remote procedure to call, and invokes it. After the remote procedure executes, its return value is then marshaled by the skeleton and sent back across the network to the client stub, which unmarshals it and returns it to the client application. This entire process transparently bridges the client and server processes over a network connection. To illustrate, consider a client application needing to fetch user data from a remote database service. First, the client code calls a method on its local stub object. This stub then packages the method name and any arguments into a network message. Second, this message is sent over the network to the server, where the skeleton awaits incoming requests. Third, the skeleton receives the message, unpacks it, and locates the actual method on the remote service implementation that corresponds to the client's request. Fourth, the skeleton invokes that method, passing along the recovered arguments. Finally, once the remote method completes, the skeleton packages its return value and sends it back to the client stub, which then returns the result to the original client application. The concepts of marshalling, converting data structures or objects into a format suitable for transmission, and unmarshalling, reconstructing the data at the destination, are central to how stubs and skeletons operate. This entire mechanism provides location transparency to the client, meaning the client does not need to know where the service is located or how it communicates over the network. It simply makes a local-looking call. Different RPC frameworks might use various protocols and data formats for marshalling, but the core responsibility of these components remains consistent. Ultimately, stubs and skeletons are the unsung heroes of distributed computing, simplifying complex network interactions into straightforward function calls. They allow programmers to focus on application logic rather than low-level network programming, enabling efficient development of robust client-server applications by making remote services appear as if they were right next door.
If this helps you fix faster, like, subscribe, and keep debugging with us.